I had it all set up, but I didn't push go. There we go. Now I'm recording. Okay, so there's the momentum, right? If I want to find the velocity of the two of those, I know that this is equal to the combined masses times velocity, right? Does that make sense? Okay, so if I want to find the velocity, then I'm just going to divide the momentum by the combined masses, right? So the velocity of the bullet and block is equal to 42.2016, right? That's the momentum, divided by the sum of the two masses, which is 0.0448 plus 1.73. So what is that?
1.818.
1.818 meters per second.
No,
Right?
no, I don't know.
Is that right?
Doubt it.
Oh. Oh, I thought somebody was really giving me a real answer here.
23.778.
Oh. Got the 8?
He says 1 point.
23 point, yeah, that's not quite gonna work, is it? 23 point what?
778.
Oh, come on. There we go. Okay. Calculated. Okay, so that's the velocity and also the speed then, right? Okay. So if I want to find the kinetic energy, now I can find the kinetic energy, right? Because I used the conservation of momentum to find the speed of the bullet and block, right? That's pretty fast, but it's not that fast. Right? And so let's calculate the kinetic energy then. So the kinetic energy of the combination of the two is just going to be 1/2 times the combined mass times the speed squared. What's that?
501.74.
It's a lot lower. Lost a lot of kinetic energy, didn't it? Right? Is that surprising? Not really, because kinetic energy is primarily dependent on speed, right? Dependent on the square of speed, but only linearly dependent on the mass. Okay? So yeah, our mass increased a little bit, but our speed went down a lot, right? Okay, so then we want to know what percentage of the kinetic energy is lost. Well, we could just as easily say what percentage of our original kinetic energy is kept, and then just subtract that from 100, right? Does that make sense? So if we take this ratio then, 501.74 joules out of an original 19,876.95 joules is about what percent?
Oh, what?
Is that like 20%? It's gonna be like
10 slowest.
What?
Oh,
Okay.
1.
Oh, yeah, it's a little number.
Yeah, not like 25.
It's about what?
0.02 is
So-
actually really close.
So, I mean, it's,
Yeah.
as a
0.05.
percent, what it's so 2.5?
2.5%.
Oh.
Oh, it's 25. I was like, oh.
So about 2.5%, 2.5% of the original kinetic energy is it was kept, right? Yeah, so that's how much energy is transferred into the block. So we lost how much? 97.5% of the original kinetic energy is lost when the bullet embeds itself in the block,
Wow.
right? It's a lot.
I don't want to get hit by the bullet.
No. And that's why, okay, so why are bullets so dangerous? I mean, they're dangerous for lots of reasons, right? I mean, they penetrate, so that makes them dangerous.
They
But
have all that kinetic energy machine, they dump it into whatever it hits
Yeah.
really fast.
and I don't want to like talking about like weapons so much, but it's if you look at like weapons that are used to be really deadly.
Are you telling us to bring this to school?
like if you look at like an M16 or something, it's a really small round, right? But it's really fast, and they're designed so they tumble, right? They're a little bit, the bullet is a little bit misshapen, so they don't spin properly, right? They spin in a weird angle, and so that means that when they hit a target, they can dissipate, they fragment, they dissipate their energy better, right? So you get,
16 bullets?
MC, yeah.
They don't fly? They don't?
No, they don't spiral, they don't, when they go through the rifling, they tumble just a little bit. So when they hit, they come apart. When they hit a target, they come apart, they turn sideways and they come apart. And so they're designed to fragment, and the reason they're designed to fragment, and this kind of, once again, I'm not a fan of this, but the physics is the physics. Instead of then just going right through a target and not.
Destroys it.
Right, I mean, it
Obviously, they're
fragments so
small,
that energy can be dissipated. And you got all this tremendous amount of energy, right? That's what's so destructive. Yeah.
Is that why you're teaching us how to make trebuchets, so we can weaponize it?
Yeah, yes, exactly.
So like, when we're talking like it tumbles a little bit, like, would we even be able to see how much it tumbles, or does
No,
it tumble?
you can't see, it's going pretty fast. I
Or
mean,
like, if we were to slow it down, could we see like the end, like as it's spinning?
I think so.
Let's try it.
Let's not. All right, so I think that's, well, let's see.
Okay, good job.
Okay, one more thing, and
Okay.
then we're
Wait,
pretty good, yeah.
Can we do the question that I wanted to ask you?
You guys wanna do that question
Yeah,
first?
yeah.
Okay, do that question, that's a good idea.
Do the similar question, which is number 3.
Sorry.